Welcome back, Patriots. Let's go ahead and get started on Unit 4. Now, the main focus of this entire unit is going to be the interaction between the equation of a line, the way that's written out as like y equals mx plus b, that form that you see right here, and the way that it looks whenever it's graphed on an xy coordinate plane. So we're going to be focusing a lot on that in the next few days. Now, today specifically, we're going to be talking about how the different forms of an equation can be transformed back and forth between each other and what all these things mean. We're going to be talking a lot about slopes and y-intercepts and points today, but we're not actually going to be putting them anywhere on a graph. We will start that up next lesson. So for now, just kind of go with me. This will all make sense once we all put it all tomorrow. Today's kind of kind of building your tool set. Next time we'll actually use those tools. So the first thing we kind of talked about this last unit is slope-intercept form. Y equals mx plus b. Now we talked about m, the number in front of x. That one stood for our slope. We also talked about b, that number out on the end, the constant, was the y-intercept. And quite frankly, this is why it's called slope-intercept form, because you've got the slope here and the intercept there. Slope-intercept form. Now, we've also got another format called point slope. Point slope is very distinguishable because it's got these parentheses in it. Okay, so if you ever see those parentheses like that, you're looking at point slope. Now, just like before, m, this value here, is the slope, just like it was in the previous format. Now, in this particular case, we don't have a y-intercept, but we do have another point that's labeled as x1, y1, and that's where this x1 and this y1 come in. Now, it's important to realize that this x1 and y1 in the equation have negative signs in front of them. Now, negative signs inside of a formula is your indication, it's mathematical shorthand for you to change a sign, and you'll see what that looks like when we get down to the examples below. The last one, honestly, is the least useful of them all. It does have some uses, so it's not completely useless, but it doesn't have as many uses as slope-intercept or point slope, and that is standard form over here on the right. That's ax plus by equals c, and a, b, and c are all integers. Now remember, it would help if I could spell that right. That's not a G either. G-E-R-S. Okay, integers. Integers are all of your positive and negative whole numbers, so you're not going to get any decimals or fractions with A, B, and C. And X and Y, easy identifying feature on this, are both on the same side of the equation, or of the equal mark. So easy way to see that. Okay, now let's go through these and first off identify what format they're in, slope-intercept, point slope, or standard, and then we're going to identify the different parts that are in it. Okay, so the first one, y equals 3x minus 4. Now when I go up and look at my different formats, there's no parentheses, which means it's not point slope. There are x and y are on different sides, so it can't be a standard form. This one's got to be slope-intercept, and I'm going to abbreviate that slope-intercept just because I'm trying to go faster. Okay, so now we're going to identify the different parts. M equals. Now remember, we saw above, m is that number in front of x, not the x itself. So that means that my slope is going to be 3. And just like your last unit, we're always going to write it as a fraction, so it's 3/1. Now, the y-intercept is b, and that is going to be the constant. Okay, that was this constant on the end. And so that one is -4, but again, we always write that as a point, so it is 0, -4. Promise that's a 0, it just looks kind of funny because I had to double write it. 0, -4. Okay. Now, number 2, I'm looking at this and I see that x and y are both on the same side of the equal mark, which tells me that is a standard form. Abbreviation for standard is STD. So standard form. And now we're just going to identify A, B, and C. Now you'll notice over here, A is the number in front of x. So A is just 4. I'm seeing that here. B is the number in front of y, another 4. And C is the number on the other side of the equal mark, which is 56. Okay, number 3, 1/3 x minus 4 equals y. Now, I want you to remember that it does not matter which direction I write an equal mark. I could switch them around. So this equals y over here. I could write it on this side, y equals. And if I did that, that would make it look a lot more like slope-intercept form. So remember, it doesn't matter what direction we write that equal mark. So this one is slope-intercept. And let's go ahead and identify our slope and y-intercept. Slope is the number in front of x, so we're talking about this number here, which is 1/3. And our y-intercept, again, is the number out there on the end, and the sign does go with it. I didn't mention that earlier, but it is true. So 0, -4. Okay, now let's look at number 4. And the first thing that I see is I see the set of parentheses, which is my telltale sign that this is going to be point slope form. Point slope. I'm abbreviating that PTSLP. Now we're going to identify our slope and our point. So M equals, and it's the number out in front right here. So it's just M equals 3. And we always write as a fraction, so 3/1. And now the point that's on this thing. Now remember we talked about how this guy had a plus sign on it. And we talked about these minus signs right here being mathematical notation to change a sign. So what I'm going to do is whenever I plug these numbers in here, -7 and -4, I need to change those signs. Now this 7 is in the x1 position. So that is my x term. So that is 7, and I change the sign to make it +7. Over here, this -4, if you look up at the top, is in the y1 position. And so I'm going to put it in the y1, or the y position, and change the sign, and it is +4. There is a very good reason why we're changing the sign. That's something I can explain to y'all later on. But for now, I need you to just take it on faith. You're going to change the signs whenever you have x1, y1 in point slope form. All right, let's look at number 5. 2x plus 45 equals y. Again, the x and y are on different sides, so it's not standard form. There's no parentheses, so it's not slope-intercept. Again, if I move that y to the other side, just like number 3, this would be a slope-intercept. I'm not going to write it that way, like I did last time, because I think we can see it by now. So now we're going to label our slope and our y-intercept. Slope number in front of x, so we're going to put that as 2/1. Y-intercept is the constant term, which is a +45, and we're going to write it as 0.45. All right, number 6. I see x and y on the left-hand side. Since they're on the same side, that tells me it is standard form. And so we're going to go ahead and label A, B, and C. A is the number in front of x, which is 9. B is the number in front of y, which is -4. Remember, sign counts. And C is the number on the other side, the constant term, which is 25. I know right now this seems useless, labeling A, B, and C. There's going to be some applications we have later on in the year where things are written in standard form, and getting used to calculating or figuring out what A, B, and C are will be important. It's just something that is going to come on later in the year. All right, looking at number 7. Again, I see my telltale parenthesis signs, tells me that I am in point slope form. So let's go ahead and label our slope. The slope is the number in front of the parentheses, which is, in this case, 1/2. And now my x1, y1. In the x position, I've got -5. Let's make sure we change the sign to make that a +5. And in the y position, I've got a +1. And let's change that sign to make it a -1. And now for number 8. Again, both sides, makes it standard form. And A, B, and C. A, number in front of x is 5. B, number in front of y is -10. And C is the number, or the constant, which is 4. Okay. Next set of skills we got to deal with, and that is converting from one form to the other. Now, in particular, the most useful form that we have of the 3 is slope-intercept, which is why we want to solve for, forgive me about that, we want to solve for y equals. Now, this is a little bit different style of solving because everything we did, especially in Unit 2 when we were solving equations, like if I had 2x = 8, I ended up working down and my answer was x = 4 because we were solving for x, and so the answer had x equals. Now in this case we're solving for y, so we're going to have y equals, but the thing that's different here is our answers are going to have x's in them still. For example, we're going to end up getting at the end y equals 3x - 7. And that's okay to do because we have this y equals. It's going to have an x on there, that's fine. Whenever I say solve, I don't mean we're getting down to x equals number or y equals number. I mean it's y equals mx plus b. So we're going to do all of our standard forms first, all the entire left column. Then we're going to come back and do all of the point slopes because I really want you to see that this is the exact same setup, the exact same steps every single time. Literally, if you do these 2 or 3 steps, depending on which one you're doing, the same thing in the same order, you will get the answer every single time. Now, I'm not going to lie, there are other ways to do this. If you can find another way that's mathematically valid, by all means, go ahead. Notice I said mathematically valid, not coincidence, not just something that looks kind of fun. It's got to be mathematically valid. If you can come up with that, I'm fine. Just realize that this is the most efficient method I've ever seen, and so that's how I want you guys to be working on them. So let's go ahead and work on this. Our first thing I'm going to do in blue, converting from standard form to slope-intercept, we're going to do add or subtract the x term. I'll do that in blue. Then in orange, I'm going to do step 2, which is divide by the coefficient of y. Do those 2 steps every time, and you will get your answers. So, first thing we're going to do, add or subtract the x term. Now, when I say add or subtract, I mean we've got to do whatever it takes to get rid of it. So in this case, my 6x is positive. So to get rid of a 6x, I'm going to subtract 6x. Now, I'm going to write whatever I do on the left, I must also do on the right. And so I'm going to write -6x here. Now, I know that's kind of funny, the place that I wrote it, but let's take a step back and go all the way back to elementary school mathematics. Okay, let's say that we did, back in the day, we did 73 plus 4. And I mean, we all know that adding vertically was much easier than adding horizontally. So you were taught to do something like this, to transfer it to a vertical problem. And if you were to write 73 plus 4, your teacher would have walked in and say, whoa, 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 you lined that up wrong. You've got to make sure that you line up your 3 underneath the 4. And why do you do that? Well, because we know that the 3 is in the 1's place and the 7 is in the 10's place. and the 4 is in the ones place, and technically speaking, there is this 0 over here in the tens place that we don't even write. And so because of that, our 3 and our 4 must be lined up because they're ones. Our 7 and our 0 must be lined up because they're tens. And when I do that, I'm able to just add my two ones digits straight down, and I'm able to get 3 plus 4 equals 7. And then I can add my two tens digits straight down, and that's going to give me a 7. So the answer is then 77. Okay, that exact same concept is what I'm going to be doing over here. I've got to combine or put like terms and stack them vertically. You see, this 12 is a constant, and this negative 6x is a x term. It's got a variable in it. Those are not the same things at all. I've got to actually stack those on top of each other. What's actually going on here is that there's really this plus 0x that we're not writing, just like there was that 0 in the tens digit on the other problem. The reason I make a huge deal about that is because if you were to write the negative 6 beneath the 12, you might be tempted to try and combine those as if they were like terms, and we don't want to do that. So let's just write off on the side, prevent that problem from happening. So what ends up happening is these two go away. I'm left with 3y on the left, and then I've got 12 minus 6x on the right. And now, in orange, I'm going to do step 2. Now, what we always said in Unit 2, the last time that we did solving, was whatever you do on the left, you have to do on the right. Now, that worked out great because we were dealing with stuff like this. Well, actually, just like this, where there is only one term on each side. So we said whatever you do to the left, divided by 2, do to the right, divided by 2. Well, now that things are a little bit more complex, we've got to be more complete with that. It's not just whatever you do to the left, you do to the right. It's whatever you do to one thing, you do to everything. So if I'm going to divide this by 3, divide by the coefficient of y, I have to do that to everything. Not just to the 6, not just to the 12, to everything in the equation. So now, these two 3's are going to cancel out. That leaves me with y equals 12 divided by 3 is 4. Negative 6 divided by 3 is negative 2. And then the x goes along for the ride. Now, let's go ahead and see what our slope and y-intercept are. Remember, the slope is the number in front of x, the coefficient of x. So it is negative 2 over 1. The y-intercept is the constant term, which is, in this case, the 4. So our y-intercept is 0, 4. Okay. By the way, they're all going to go a lot faster than that from here on out because I don't have to do all that explanation. Okay. Same process as before. I'm going to drop this down. I'm going to first add or subtract the x term. Here, 20x is positive. So I'm going to subtract 20x, and I'm going to write it out here on the right, lining that stuff up again. These guys cancel, leaving me with negative 4y is equal to negative 8 minus 20x. Now, I am going to, in orange, divide by the coefficient of y, divide everything by negative 4, and then that leaves me with y equals, forgot to tell you those canceled out, negative 8 divided by 4, negative 8 divided by negative 4 is positive 2. Negative 20 divided by negative 4 is positive 5, so plus 5x. So my slope, number in front of x, coefficient of x, is 5 over 1. Y-intercept is the constant, so it's 0, 2. All right, I hope you can see, the only thing that changed between those two problems was the numbers. Process is exactly the same. So let's go through and do the next one. Here, we've got the y leading instead of the x. Does it matter which one comes first? We're still going to subtract that x term. Those are going to cancel out, leaving me with 4y equals, now I'm going to do something a little bit different here because I want to actually get my x in front. Remember, it doesn't matter what order you add or subtract as long as the signs remain constant. See, this x is going to be negative and this 16 is going to be negative, which is going to make it look a little bit more like the slope-intercept that we are used to. Now I'm going to divide everything by 4. And that's going to leave me with y equals, those two go away. Now, negative x divided by 4. Remember that negative x is the same thing as negative 1 times x. So this is a negative 1 divided by 4, means my slope here is negative 1 over 4 times x. Negative 16 divided by 4 is negative 4. So my slope, m, is negative 1 over 4, like we just said. And y-intercept is 0, negative 4. Okay, last one of this type. Same old process. Here I've got a negative 3x. In order to get rid of a negative 3x, I'm going to add 3x. Those go away. Negative 4y equals, and now I'm going to choose to write that 3x in front. The 3 is positive, the 15 is also positive. And now we're going to divide everything by negative 4. Those two go away, leaving me with y equals 3 over negative 4x. Now, 15 divided by negative 4 is negative 3.75. And you might be saying, Mr. Love, why in the world are we putting a decimal here, whereas we've been putting fractions everywhere else? Well, again, you'll see that when we start graphing things in the next few days. For slopes, fractions have meaning, and we'll see that a lot when we start graphing them. Y-intercepts, the fractions are not as important. For y-intercepts, it's whatever helps you visualize it best. And so if you want to say 3 3/4, that's fine. If you want to say 3 and 3.75, that's fine, as long as you can visualize where that is on the graph. And we'll show that when we get to the graphing sections of this unit. So my slope is negative 3 over 4. And my y-intercept is 0, negative 3.75. Oh, by the way, make sure you're always writing your points with parentheses around them and a comma in the middle. Good, solid habit to get into. Okay, last section. This one's got 3 steps on it, but honestly, steps 2 and 3 are going to happen at the exact same time. So this one is going to happen in blue. These two together are going to happen in orange. So first thing we're going to do is distribute the slope, distribute the m. Now, we had those telltale parentheses. We've always got the slope out in front of it. We're going to distribute that. So what ends up happening is this y minus 4 is going to drop down. Now, 3 times x is 3x. 3 times negative 3 is negative 9. It's a distribution just like we did way back in the first unit of the year. Now, we're going to take care of those steps 2 and 3, which actually happen at the exact same time. So here we go. We're going to add y1. Remember, y1 was this term. So we're going to add plus 4. And now we're coming back to this concept. Okay, head over here. Which column is this going to go in? The 3x or the negative 9? Well, they're both constants, so it's going to line up underneath the negative 9. Those go away, leaving me with y equals 3x. Negative 9 plus 4 is negative 5. And so now my slope, coefficient of x, 3 over 1. Y-intercept is 0, negative 5. Sign is important, and the 0 coordinate is also important. All right. Oh, by the way, that step 3 that we didn't talk about, combine the constants. That whole thing actually happened right here whenever I did that column. So that's what I meant by the steps 2 and 3 kind of happen at the same time. Okay. The left side gets written down, y minus 3 equals. Now we're going to do our step here. We're going to distribute that. 1/3 times x is 1/3 x. 1/3 times negative 12. Now, if you don't remember that, you can always just type it. 1/3 times negative 12 will be negative 4. That's effectively the same thing as dividing by 3. Now we're going to add 3, again, lining it up in the constants column. Those are going to subtract out. Y equals 1/3 x. Negative 4 plus 3 is negative 1. So, my slope, coefficient of x is 1/3. Y-intercept is 0, negative 1. That b value there on the end. Again, sign is important. Again, I hope you're seeing same process between those two. Now, let's go through and do this one. Drop my line down. Y minus 4 equals, transfers down. We're going to distribute this negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Now, let's go ahead and add 4 to both sides. Those are going to go away, leaving me with y equals negative 2x. 6 plus 4 is positive 10. Y-intercept now is the number in front of x, the coefficient of x, negative 2/1. Y-intercept, 0, and then 10, pulling that value off. Okay. Now we're moving. Last example of the day, and then the lesson is yours. So y plus 6 equals, gets written down. Let's distribute this negative 3/4. So negative 3/4 x. And now, if you don't remember it, negative 3/4 times 12 is negative 9. Subtract 6. Those go away. And that leaves you with y equals negative 3/4 x. Negative 9 minus 6 is negative 15. So my my slope, coefficient of x is negative 3/4. And the y-intercept is 0, and then my b value, negative 15. So once again, I hope you're seeing exact same process all the way down, which means I could give you any standard form and any point slope with any numbers, and all you've got to do is those same 2 steps over and over and over again, which you're going to have to do on your assignment. So that's all we got. Feel free to reach out to me with any questions, and you guys have a wonderful day.